Hey everybody, I hope you had a good day, and notice the time I'm making this video that there was a couple people that haven't finished the Google form. So if you could just please complete that so that I can release everybody's grade, I might appreciate it. So once I have them all in, then I will release everybody's grade, and so you'll see what you got on those. But today we're going to start with chapter 10. We're going to start with graphing square root functions. So as we see here, a square root function is a function that contains a square root with the independent variable in the radicand. The parent function for the family of square root functions is f of x equals the square root of x, where in this case the domain would be x is greater than or equal to 0. So why would the domain be greater than or equal to 0 inside of here? Well, that's because you can't have a negative inside of the radical sign. So if you have 0, that's the least it could be, because once it's less than that, you'll have an imaginary number, so you can't have the square root of a negative, so 0 is the least it could be. Now that could change if there's something different inside the radicand. If it was like x plus 3, which we'll see in a second, well then x couldn't be anything less than negative 3, because once it was less than negative 3, it would be negative inside. So we're going to explore these options of what the domain could be, and then graph one, and then we're going to let you guys practice some. So for this next problem here, it asks us to describe the domain of f of x equals 3 times the square root of x minus 5. So if we have x minus 5 inside of here, we know that that can't be a negative. So we know x minus 5 has to be greater than or equal to 0. So we go ahead and solve. We add 5 to both sides. And x is greater than or equal to 5. So when you're trying to find out what the domain of a radical function is, if it's the square root, then you put whatever's inside of the radical sign, greater than or equal to 0, and then you solve. And that's how you'll get your domain. Now, to graph the function, we're just going to make a table, just like any other time. But with our table, normally I would always suggest picking a couple of negative numbers, 0 and then a couple positive numbers if we didn't know what was going on. But in this case, we want to see what the domain is first. So the domain is going to wind up being x is greater than or equal to 0. So when I make my table, I'm going to start with 0. And I'm just going to pick a couple perfect squares. So 4 would work out nicely, 9, and 16 I can't graph unless I change what x goes by, which you're going to have to do sometimes because you won't be able to fit enough points on the graph, but we could probably just get away with graphing these 3 points here. So if I plug in 0, the square root of 0 is 0, plus 3 is 3. The square root of 4 is 2, 2 plus 3 is 5. And the square root of 9 would be 3, 3 plus 3 would be 6. So I'll go ahead and I'll graph these. I'll start at 0, 3. 4, 5. And 9, 6. So the way this graph looks is it's a sloping graph. That looks like that. Alright. So that is how we graph this radical function. Down here it wants us to describe the range. Well, the values of y would be anything from 3 and up. So it would be y is greater than or equal to 3. Alright, so that's all we're going to ask for you to do today. So just go ahead and try some problems on big ideas, describe what the domain of radical functions are, and then graph a few. Sometimes your functions might look a little different inside the radical sign, so you have to first decide what the domain is, and then use that domain to come up with more points. If there's something happening inside the radical, like x plus 1, adjust your x value so that you have perfect square values that come out so that you're able to easily graph it. All right, well, good luck. If you have any questions, please write them on the Google Doc.